This is a presentation of the factors involved in global warming, or climate change as it's now called. I'm Kenneth Schultz. It's presented without the emotion and without the politics often associated with the subject of climate change. It's in the form of a question and answer session. So let's get started. Carbon dioxide is a molecule comprising one atom of carbon bound together with two atoms of oxygen, hence its chemical formula CO2. Carbon dioxide is a tasteless, odourless trace gas comprising around 400 parts per million, or just 0.04% of the atmosphere. CO2 is a plant food. Without CO2, there would be no plant life and hence no life on Earth. Professor Ian Plimer had this to say about carbon dioxide during his address to the UK Parliament.
Carbon dioxide is a natural gas. It has dominated the atmosphere for an extraordinarily long period of time, and we now are at a dangerously low level. If we halved the amount of carbon dioxide in the atmosphere, we would have no terrestrial plants. Carbon dioxide is plant food. It is not a pollutant. To use words like pollution with carbon dioxide is misleading and deceptive.
CO2 concentration in the atmosphere has been slowly declining for the past 500 million years as it is taken up in rocks, oceans and forests. It has been as high as 10,000 parts per million in the past. Greenpeace co-founder Dr. Patrick Moore explains.
CO2 is the most important food for life on Earth. All life depends on CO2 for its existence. That is the only place the carbon in carbon-based life has come from. The CO2 came from the Earth from volcanism, but much less of it is coming out today because the Earth has cooled due to the decay of the radiation that makes it hot inside in the first place. And now the Earth is way cooler than it was at the beginning of the Earth, when most of the CO2 was put in the air. That's why CO2 has constantly declined in the early years.
The greenhouse effect is the warming of the Earth's surface and the air above it. It's caused by gases in the atmosphere that trap some of the energy from the sun. These heat-trapping gases are called greenhouse gases. Without the greenhouse effect, Earth would be too cold for life to exist. Major greenhouse gases are water vapour, the most important, ozone, carbon dioxide, methane and nitrous oxide. Though naturally present in the atmosphere, solar radiation passes through the atmosphere and warms the Earth. Some of the heat is re-radiated as infrared radiation, and some of this radiation is trapped by the greenhouse gases, causing warming of the atmosphere, effectively surrounding the Earth with a warm blanket and thus making the planet habitable. The greenhouse effect is natural. It is important for life on Earth. Without the greenhouse effect, the Earth's average temperature would be around minus 19 degrees Celsius, 0 degrees Fahrenheit. Earth would be locked in an ice age. Because of the greenhouse effect, the Earth's actual average temperature is around 14 degrees Celsius, 57 degrees Fahrenheit. Carbon dioxide is not the bogeyman, some people say. Instead of demonising carbon dioxide, we should revere it for two very important reasons. CO2 is a plant food. Without CO2, there would be no plant life and hence no life on Earth. And CO2, together with the other greenhouse gases, raises the average temperature of the Earth by around 35 degrees Celsius, making the average temperature around a comfortable 15 degrees Celsius. Without the greenhouse effect, the average temperature of the Earth would be around minus 19 degrees Celsius. The planet would be uninhabitable as it would be covered in one large ice sheet. Climate change is a natural event. The climate's been changing for hundreds of millions of years. It's always been changing and it always will change. Some of the factors contributing to climate change include variations in the sun's output, changes in the Earth's orbit, and changes in the tilt of the Earth's axis. And as our solar system travels around the Milky Way, it from time to time enters areas of increased cosmic radiation. The cosmic rays help cloud formation, which promotes global cooling. And recently, a hypothesis was put forward that man-made carbon dioxide emissions are contributing to climate change. I'll talk more about that later. During the last ice age, most of Alaska and North America were covered in ice.
I told you about this already, how much ice there was on these cities just 21,000 years ago.
Since the end of the last ice age, about 10,000 years ago, temperatures on average have been slowly rising with warmer and colder periods along the way. From 250 BC to around 400 AD, Europe experienced an unusually warm period. Then temperatures declined again until a period known as the medieval warm period from 950 AD to 1250 AD, when temperatures went up again. Between the 13th and 19th century, the northern hemisphere was in the grip of a little ice age. Temperatures dropped worldwide as summers became cold and wet, while winters became colder, long and harsh. In London, even the mighty River Thames froze. According to historical data, between the 17th and 19th century, the River Thames froze for nearly 24 times. During Britain's worst recorded frost in the winter of 1683 to 1684, the Thames was completely frozen for 2 months, with ice up to a foot thick. The painting by Thomas Wick shows the frost fair that took place on the Thames during that winter. Glaciers have been melting since the end of the last ice age and have been observed shrinking since the middle of the 18th century, long before human-caused CO2 emissions became significant. Scientists Leclerc, Erlemans and Cogley showed that glaciers were melting even in 1850 when they first made observations, or observations were first made. And that since that time, the loss of glacier ice has been fairly constant. The loss of glacier ice since that time has added about 10 centimetres to global sea levels. A few years ago, I went on a cruise along the Alaskan coast. The cruise ship pulled into an amazing place called Glacier Bay. The cruise ship pulled up a few hundred metres from the glaciers and then slowly pivoted through 360 degrees to give the passengers amazing views of the glaciers. It was a breathtaking experience. It was so exhilarating, I celebrated with a frozen margarita. An officer from the National Park Service on board the cruise ship gave a commentary on Glacier Bay. She said that the shoreline was completely covered by ice just 200 years ago. When explorer Captain George Vancouver explored the area in 1794, he couldn't enter Glacier Bay because it was choked with ice. It was covered by a glacier more than 4,000 feet thick and up to 20 miles wide. And the glacier extended more than 100 miles to the St. Elias range of mountains. You can see from the map that Glacier Bay is a very large inlet and yet just 200 years ago it was covered by a giant glacier. But by 1879, naturalist John Muir found that the ice had retreated 48 miles up the bay. By 1916, the Grand Pacific Glacier was 65 miles from Glacier Bay's mouth. All of this occurred before any significant amount of man-made CO2 entered the atmosphere. On the same trip, I got to cross off an item on my bucket list, namely to walk on a glacier. This event occurred at the Athabasca Glacier in Alberta, Canada. We all got on special buses at the Athabasca Discovery Centre, where we were ferried down the mountain and part the way up the next to the start of the glacier. We got off the buses and walked around on the glacier. A wonderful experience. When we got back to the Discovery Centre, I saw a sign that said the glacier reached the area of the Discovery Centre about 150 years ago. Since that time, it had retreated down the mountain and part the way up the adjacent mountain. This retreat occurred over a 150-year period, most of it before man-made CO2 entered the atmosphere. The study by Leclerc, Ullmans and Cogley of past sea level rises gives a sea level rise of just 9.1 centimetres for the period 1850 to 2005. This graphic shows global mean sea level rises from 1992 to 2017, as compiled by a number of institutions, including Australia's CSIRO and NASA. This shows an average sea level rise of just 3.31 millimetres per year. The next graphic shows extrapolation of sea level rises to the end of the century for various countries. It is nothing like the 6 metres as predicted by Al Gore. To answer this question, we need to look at what scientists call the scientific method and how it relates to global warming. The scientific method begins with the observation of a phenomenon and then forming a hypothesis to explain this phenomenon. The next stage in the scientific method is to carry out experiments and measurements to test the hypothesis. If experiments disprove the hypothesis, then it must be revised. If a considerable number of experiments support the hypothesis over a period of time, its status is raised to that of the theory and is generally accepted by the scientific community. However, this is not consensus. It is just acceptance that the theory has stood up to a considerable amount of testing and experimentation. But one test result could still invalidate the theory. In relation to global warming, a researcher observed that global temperatures experienced a slight rising trend in the 20th century. The observer formed a hypothesis that the temperature rise was due to increased amounts of CO2 being pumped into the atmosphere from burning fossil fuels. That's where we're at. To my knowledge, there have been no experiments or measurements to support the man-made global warming evidence. There is no evidence in the scientific sense. All we have are computer models, and that's all they are, computer models of future climate change based on information fed into the computers. That is not scientific evidence. On the other hand, although billions of tonnes of CO2 are pumped into the atmosphere annually, there has been no discernible rise in global temperatures for the past 20 years. That would seem to indicate the global warming hypothesis is not valid. At best, man-made global warming is just a hypothesis. As climate changes very slowly over long periods of time, This hypothesis needs to be tested by CO2 and temperature measurements over the next 50 years or so. I've answered a number of questions in this video, which I hope you found useful. I'll leave you with the final question. Do you think the man-made global warming hypothesis is valid or not?